Hi guys, welcome back. I hope you're ready to embark on a journey into the fascinating world of Arduino programming. In today's video, we're kicking off a new series where we'll explore the ins and outs of Arduino programming. And guess what? We're starting with a classic, the Knight Rider LED circuit. Before we dive into the code, we'll be using the Woqui online tool for this tutorial. If you're not familiar with it, check out our previous video where we walk you through the wonders of Woqui. I've dropped the link in the description, so give it a watch if you haven't already. Now, let's get our hands dirty with the hardware. I've got an Arduino Mega board here. And on our virtual breadboard, I've added 3 LED to create a snazzy LED strip. To make things simple, we'll connect the ground of our Arduino board to the breadboard, creating a common ground. Each LED ground pin then connects to this common ground. After that, we'll connect the LED to pins 0, 1, and 2 on the Arduino board. Simple, right? Now, the fun part, coding. We'll configure pins 0, 1, and 2 as output pins. Then, we'll write a basic code snippet to create the iconic Knight Rider LED pattern. It's a classic. In the world of Knight Rider, these LEDs symbolize the iconic scanning motion of the car's front light, moving back and forth. Each LED turning on and off creates that visually striking effect. Here's a step-by-step breakdown of the code. Digital write 0, high. This turns on the first LED. To initiate the scanning motion, delay 400, a brief pause, creating a short duration of illumination. Digital write 0, low, turns off the first LED. Digital write 1, high, activates the middle LED, simulating the scanning motion moving towards the left. Delay 400, another short pause. Digital write 1, low, turns off the middle LED. Digital write 2, high, switches on the leftmost LED, continuing the scanning motion. Delay 400, once again, a brief pause. Digital write 2, low, turns off the leftmost LED. Digital write 1, high, activates the middle LED, now moving back towards the right. Delay 400, pause. Digital write 1, low, turns off the middle LED. The cycle then repeats, creating that mesmerizing back and forth motion reminiscent of the Knight Rider car's light. Each LED takes turns lighting up and simulating the scanning motion, creating a visually appealing effect that captures the essence of the iconic Knight Rider circuit. Give it a run by clicking the Start the Simulation button, and voila! You've got yourself a Knight Rider LED circuit. But wait, there's a catch. This code is a bit, well, ugly. What if our requirements change? What if we decide to add or remove LED in the future? That's where pro coding techniques come in handy. Let's optimize this code. In the Pro version, we keep the circuit diagram as is and modify only the code. We introduce a variable, LED_count, which you can change according to the number of LED in your project. Here's the optimized code. Here, we declare a variable LED_count and set it to 3. This variable will dictate the number of LED in our circuit. Unlike the previous code, changing the number of LED now only requires updating this single variable. This loop iterates through the LED from the first, index 0, to the last, index LED_count, 1. It turns each LED on, introduces a delay, and then turns it off. The effect is a seamless forward scanning motion. Here, we initiate a backward scanning motion. It starts from the second to last LED and goes backward to the second length. E.D. Similar to the forward loop, it turns each LED on, introduces a delay, and turns it off. Now, give it a test run, and it works just like the previous code. The beauty of this approach is that if you decide to change the number of LED, you only need to update the LED_count variable. The loops will dynamically adjust, ensuring that the scanning motion remains consistent regardless of the number of LED. As an example here, we change LED count to 4 and do a test run, and you can see there are no big changes in code. But it adjusts with our project easily. This pro-level coding technique not only optimizes the code but also makes your project easily maintainable and scalable. It's a great example of how thoughtful coding practices can enhance the flexibility of your Arduino projects. And there you have it. You've not only created a Knight Rider LED circuit but also learned how to do it like a pro. Thanks for joining us in this Arduino adventure. If you enjoyed this video, give it a thumbs up, subscribe for more Arduino awesomeness, and remember, keep coding, keep creating, and may your LED always shine bright. See you in the next one.